So very, very good morning to all of you. I welcome you all for the morning session class on operating system. So in the last class, uh, I was discussing the concept of your banker's algorithm, right? So we have learned in banker's algorithm, the first part of it, that was a safety algorithm, right? So the main purpose of that safety algorithm was to check whether the system will be in a safer state or not anta. Okay, so by applying that safety algorithm, so we have learned one problem also on that safety algorithm, right? So in today's class we will try to see the other part of your banker's algorithm, so why it is used, and later on we will try to see one more problem related to that. Okay, so let us start with the today's session. So I will just share the today's slide for you. Just a moment. Yes, so please keep your books with you, people, so that whenever I start solving the problem, you try to update that in your book also simultaneously. Okay, so is the slide visible to you, people? Is the slide visible to you? Yeah, right. So this is the second part in your banker's algorithm. Okay, that is a resource request algorithm. So one thing we have already learned, that is safety algorithm. So second one is resource request algorithm. Now, why this algorithm is used antandandre? So whenever any process, suppose it requests some additional resource. Okay, so then we, before allocating the resources to that particular process, so this algorithm is applied just to check whether our system will remain, say, in a safer state or not if we allocate these additional resources anta. Okay, so for that purpose this particular algorithm was introduced in your banker's algorithm. Okay, so let us understand this particular algorithm first. Okay, so as I said, the first point is, so this algorithm determines whether the request made by a process can be granted or not anta check madakoskara this algorithm is used, that is resource request algorithm. Okay, so this is what the variable we use. It is a vector variable. Okay, the variable name is called request of I. So I can be your process, any process. It can be 0, 1, 2, 3, like that. Okay, right. Here you can see there is a one small example I have took here. Request I of j. What does that indicates? Okay, means I means that process. Okay, it can be process P0, process P1, process P2, etc., like that. Okay, so whereas within the square bracket we have written another variable called j that indicates the resource type. It can be resource A, resource B, resource C, etc., like that. Okay, so request I of j is equal to k means what antantandre the process Pi wants k instances of resource j anta artha. That is what that particular thing indicates. Okay, right. Next, so this is the algorithm for your resource request. Let us see one by one what are all the steps which are coming in this resource request algorithm. So the first step is checking the request is less than or equal to the need anta first check ಮಾಡ್ಬೇಕು ನಾವು. Okay, so we already know how to calculate the need matrix, correct? So can anybody tell what is the formula for need matrix? Please unmute yourself and tell what is the formula for calculating need matrix.
Max minus allocation.
Yes, need is equal to max minus allocation. That is a formula. So it means that we have already created one need matrix. So in that particular need matrix, which process request we are considering, so simultaneously that process need value we have to compare anta artha. That's what that first point indicates. Request made by the process I should be less than or equal to the need of that particular process anta artha. That's what we are checking. Okay, if it is true, okay, then we are going to step number 2 anta artha. So if it is false means what does that indicates? If request is greater than the need means it means there is an error anta artha. So it cannot be possible. Okay, the request made by the process should not be more than the need of that particular process. So if that is the case, that's why it is written otherwise rise an error anta artha. Okay, right. Next, so come to the second step. In second step, what we are doing, we are once again checking the request made by the process, that is I request I, whether it is less than the available. Okay, so we know in our given snapshot what is the available resources anta ನಾವು ಇರುತ್ತೆ, right? So whatever the request any process is making, it should be always less than the available resource. If it is more than that, then what happens? So you cannot able to issue or allocate the resources because you don't have enough resources anta. That's why we are checking the second step. Request is less than or equal to available anta check ಮಾಡ್ತಾ ಇದೀವಿ. If it is true, then only we are going to step number 3 and we do all the 3 things here. Okay, otherwise, so we can say that there is no enough resources available and the process cannot request the resources anta. So it has to wait. That's what the otherwise indicates. Otherwise, process PI must wait until enough resources are available anta. Clear with this second point? Okay, so come to the third step. In third step, we are calculating the new values. ಯಾವ್ಯಾವುದಕ್ಕೆ we are calculating the new available value. So why we need to calculate ಅಂತಂದ್ರೆ, so if the requested resource if we allocate for that particular process, then what happens? The number of available resource will also be reduced alwa, correct? So that is why we have to consider the new available value. I will just highlight and show it to you. Okay, so this is the first thing we are calculating. This is a new value. Available is new. How you are calculating that? By using this formula. Available is equal to available minus request. Okay, right. Next, another thing also we are calculating. If we allocate the process with the newly requested resources, then the number of resources allocated will also be increased, correct? So that's why we are calculating the another calculation, that is allocation. And what is the formula for that? Allocation is equal to allocation of I plus request of I anta artha. Okay, ಏನ್ ಹಂಗಂತಾರೆ, for example, initially you have allocated one resource for the of instance A, resource A. So one resource is already allocated for process P1. Okay, assume like that. So your process P1 is requesting again one more resource of resource type A. So then what happens? Already you have allocated one resource, one more resource it is requesting. So then how much it is? 1 plus 1, it will become 2, correct? That's what that indicates. Allocation is equal to allocation plus request anta artha. Clear with this? Okay. Next, finally, we are calculating one more value, that is need value. So need value will also get changed whenever you are going to allocate the new request for that particular process. So this is a formula for calculating the next value, that is need. Need is equal to need minus request anta. Okay, so after doing all these 3 steps, you can see, so we have generated the new available value, we have generated the new need value, and we have generated the new allocation value. Okay, all these 3 things are the new values. So we have to update these things in our given snapshot. So I told while solving the problem, so they will be giving the snapshot which contains ಏನನಿರುತ್ತೆ. What are the three columns your snapshot contains? Can anybody unmute yourself and tell? What does your snapshot contains while solving the problem? You will have three columns, no? What are those three columns you are having? What are the three columns you are having? Look at this. This is your snapshot, correct? So what are the three columns you are having? Please respond. What are the three columns you are having in your snapshot? Allocation, max, and available, correct? So whenever any process made a request, so we are going to change the allocation of that particular process. Similarly, we are going to change the need of that particular process. Similarly, we are going to change the available value anta artha, correct? That's what that indicates. So if the resulting resource allocation is safe, what we have to do antantandre, so we have to update the snapshot with these new values: new available, new allocation, and new need value. Okay, so your snapshot will become changed now for that particular process. So afterwards, what we have to do, we have to again apply our safety algorithm for the new snapshot. Okay, listen to it carefully. We have to apply the safety algorithm for the new snapshot and check whether all processes will execute perfectly or not. If processes cannot able to execute properly, then we can say that the resource which a process made a request cannot be granted and now decide ಮಾಡಬೇಕು. Okay, that's how your resource request algorithm works. Okay, am I clear with this? Okay, so let us, you can understand this by solving a problem. Okay, let us take the same problem which we discussed in the last class. Okay, right. So is the slide visible to you properly? You can see here problem 1. It is just a continuation of the problem 1 which I have discussed earlier. This is problem 1. Same problem, I am just continuing. So what it says antandre, observe here. Suppose process P1 requests one additional instance of resource type A. Okay, and two additional instance of resource type C. So it is given like this: request of I ಅಂತಂದ್ರೆ ಏನಿಲ್ಲಿ process number, correct? Which is that process P1 ಅಲ್ವಾ? So request 1 ಅಂತ ಬರೆದಿದ್ದೀವಿ, correct? So request 1 is equal to ಎಷ್ಟು 102. What does that indicates? 1 ಅಂತಂದ್ರೆ resource type A, 0 ಅಂದ್ರೆ resource type B, 2 ಅಂತಂದ್ರೆ resource type C. That's how you have to understand. Okay, so this is the additional resources which process P1 is requesting anta. Now what is our intention? Observe this. ಏನ್ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕು ನಾವು? Determine whether this request can be granted immediately. ಅದನ್ನ ಚೆಕ್ ಮಾಡ್ಬೇಕು ನಾವು. Okay, whether I can able to grant this particular request or not anta. How you are doing that one? You are doing that one by applying which algorithm? Resource request algorithm. Okay, so this is the solution I have written. So what is the first step in your resource request algorithm? What is the first step? Request I is less than or equal to need I. That is the first step, correct? So apply that one. So I badli ಏನು ಬರಿಬೇಕಿಲ್ಲಿ? The process number you have to write. Request 1 is less than or equal to need 1 ಅಂತ ಬರಿಬೇಕು. So we have already created the need matrix, correct? Can you see here? This is your need matrix. What is the need matrix for process 1? What is the need matrix for process 1?
1, 2, 2.
Yeah, right. So use that one in your problem. So Okay, check this one. So 1 is equal to 1, 0 is less than 2, and 2 is equal to 2. So we can say that it is true. Correct? I am just solving that problem for you people. Please simultaneously take. Okay, so you can see here, if the first step is true, then what we have to do? We have to go to step number 2. That's what it is given here, right? What is step number 2? Request of I is less than or equal to available. Correct? You can see here. What is the available value given? What is the available value?
332.
Correct. So use that one here. Request of 1 is less than or equal to available. Request of 1 ಅಂತಂದ್ರೆ ಎಷ್ಟು? 102 is less than or equal to 332. Is it true? 1 is less than 3, 0 is less than 3, 2 is equal to 2. So it is true. Then what we have to do? We have to go to step number 3. That's what it is written here. Correct? Okay, fine. So simultaneously take in your book also. Now you go to step number 3. What we are doing in step number 3, you can see here. So we are calculating these 3 values. Available, allocation, and need. These are the 3 things we are calculating. Okay. Okay. Let us go to that. So formula for calculating available is equal to available minus request of I. Okay, so available minus request of 1. What is available value? It is 332. Correct? So I have written here 332 minus what is the request of that process? 102. How much you are going to get? 3 minus 1, 2, 3 minus 0, 3, and 2 minus 2, 0. So this is our new available value. So am I clear with this? Please respond, everyone. Artha aita ellargu? This is your new available value. So we are using this in the next snapshot. Clear with this? Okay, next. Similarly, calculate the next allocation value. So this is a formula for that. Allocation of I is equal to allocation of I plus request of I anta. Okay, so use that one. Allocation of process 1, because which process is requested here? Process P1. Correct? So we have to calculate the allocation value of that process. Okay, so I have written allocation of 1 plus request of 1. So we know what is request of 1. Correct? 102. What is allocation of 1? What is allocation of 1?
200.
Correct. So use that one in your problem. So I have written here 200. So add these two. 2 plus 1, 3, 0 plus 0, 0, 0 plus 2, 2. So what is your new allocation value? 302. So clear with this? Last one is need value. So this is a formula for calculating the need value. Need of I is equal to need of I minus request of I. So write that one with respect to the process. Need 1 minus request 1. So we know what is the request 1? 102. So need 1 we have to check in the table. What is need 1?
122.
Correct. So use that one in your problem. 122. So do the subtraction. 1 minus 1 it is 0. 2 minus 0 it is 2. 2 minus 2 it is 0. So this is my new need value. So am I clear with this? Is everybody understood these things? Please respond, anyone. Have you all understood the 3 steps? Yeah, right. Now observe this, what I have written here. I have written some statement. Read this carefully first. Okay, now we have to update the given snapshot of the system. Given snapshot ಅಂತಂದ್ರೆ ಯಾವುದು? ಇದು. This is your given snapshot. ಏನ್ ಮಾಡ್ಬೇಕು ಹೇಳ್ತಾರೆ ಅವರು? You have to update this snapshot, they are telling. Okay, with newly calculated values. Okay, and apply the safety algorithm for the new snapshot. Okay, and check for the safety. If your system is still in the safe state, then you can easily say that request can be granted ಅಂತ ಹೇಳ್ಬೋದು. Otherwise request cannot be granted. Your process has to wait ಅಂತ ಹೇಳ್ಬೇಕು. That is the answer. Clear with this? ಅರ್ಥ ಆಯ್ತಾ? So these are the new values we have calculated. Correct? Available, need ಮತ್ತೆ allocation. So I have to update that in our snapshot. Clear with this? Okay, so I will show that one. So this is the new snapshot. Can you see here? I'll just highlight that and show it to you. This is a new snapshot applying safety algorithm for this new snapshot. Observe this box carefully. I have used the bold font here. Can you see the bold font? Are you able to see
Yes.
the bold font here? Now what does that indicates ಅಂತಂದ್ರೆ these are the new values ಅಂತ ಅರ್ಥ ಅಷ್ಟೇ. Okay, which we have calculated. Remaining values we have to keep it as it is because those processes have not requested ಅಲ್ವಾ. ಯಾವ process request ಮಾಡಿದ್ದು ನಿಮಗೆ? It is process P1. So that's why we are modifying that process allocation value and that process need value. Along with that, we are able to derive the new available resources, that is 230. So remaining thing we have to keep it as it is. Okay, you can refer that need matrix which is previously present. You just copy those values for P0, P2, P3 and P4. Only those things will remain as it is. Only thing is P1 has changed here, that's it. So can you see here what was the previous need value for P1?
122.
Correct. So what is the new need value for P1 now?
020.
Correct. So remaining values you have to keep it as it is. So I'll just copy and paste it. Okay, so simultaneously do in your book also. Try to keep the remaining values as it is. Okay, so can you see now? So this is your updated need matrix. So your process P0, P1, P2, P3, P4 have the older values, correct? Only thing is the process P1 need value is changed here anta artha ashte. Similarly, in the allocation matrix you can see your process P0, P2, P3, P4 have the older values. Only thing is process P1 has the new value. That's why it is written in bold. Similarly, the previous available value, what was the previous available value? It is 332, correct? Now your new available value is how much? 230. That's it. Am I clear with this? So this is your new snapshot. Artha aita ellarigu? Okay, so now you have to apply your safety algorithm for this new snapshot and check whether all process will get execute or not anta. Okay, if all processes execute, then what is your answer? Request can be granted. Otherwise, request cannot be granted. Process has to wait anta baribek. That is the answer. Okay, so I will apply the safety algorithm now. So first I will take process P0. What is your available value? Work is equal to available. It is 230, correct? So write that one 230 and make your finish of 0 initially false. Correct. Next, finish of 0 is equal to false. Need of 0 is less than or equal to work. That is what we are going to check. So your available value will change now. 2, 3, 0. So what is your need value? You have to check. What is your need value for process P0?
743.
Right. So use that one here. 743. So is it less than this? No, it is false. Correct. So stop there itself. Start considering the next process. So I will go to here. So what is your I value now? I value is 1. So work is equal to available is equal to, since we have not calculated any new value, what is the old value of your work? Same thing you have to use here also. So 2, 3, 0. Next, make finish of 1 is equal to false. So that is your initialization step. Next, in step 2, need of 1 is less than or equal to work we are checking. Correct. 2, 3, 0 is your work. What is the need 1? What is the need 1?
0 to 0.
Correct. So use that one here in your problem. 0 to 0. So is it less than? 0 is less than 2. 2 is less than 3. 0 is equal to 0. So it is true. Correct. Next, go if second step is true means you have to go to step number 3. Step number 3, you know, work is equal to work plus allocation. Correct. So what is your work value? It is 230. So use that one, 230. So what is the allocation of 1?
302.
Correct. So use that one here. 302. So add this ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ?
532.
532. Right. Correct. So what is the next step you have to do?
Finish of 1 is equals to true.
True. Correct. So that indicates the process P1 has completed its execution anta artha. Correct. So what will be your safe sequence now?
P1.
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 Correct. Right. Next, go to the next process, that is process P2. Correct. Once again, apply your safety algorithm. I is equal to 2 now. Work is equal to available is equal to how much? What is your new available value now? We have calculated previously, correct? It is 532.
532.
That we have to apply here. 532. Next, make finish of 2 is equal to false. Next, need of 2 is less than or equal to work we are checking now. 5, 3, 2. What is need of 2?
600.
Correct. So use that one. 600. 600. Is it less than? 6 is less than 5? No, it is false. You can write that as false. Right. So consider your next process. So your next process will be process 3. Okay. So your work value has not changed because we have not calculated here. So use the same work value. 5, 3, 2. Make finish of 3 is equal to false. Check need of 3 is less than or equal to work. 5, 3, 2. What is need of 3?
011.
Correct. So use that one. 0, 1, 1. So is it true? 0 is less than 5. Yes, it is true. So go to step number 3. Work is equal to work plus allocation of 3. Correct. What is the work value? 5, 3, 2. So what is the allocation of 3?
2, 1, 1.
Correct. So use that one. 2, 1, 1. So add this. ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ?
7, 4, 3.
Correct. So make that process as finished now. Correct. So finish of 3 is equal to true. Now what is your safe sequence?
P1, P3.
Correct. P1, P3. See, if the session ends, please try to log in again. Okay. I will just complete this particular problem. Okay. Now you have to consider the next process. Okay. So go to the next slide. Okay. Which is the next process which is remaining? It is 4. So what is your work value? You got 743. Correct. So use that one here. Work is equal to available is equal to 743 and initialize 4 is equal to false. Okay. Check need 4 is less than or equal to work. What is need 4?
4, 3, 1.
Correct. So use that one.